This NerdCast is on the concept of the lactate shuttle and its role in training and performance. So, what I'm going to cover is a deeper look into the body's lactate shuttle, and I'll define first what is lactate and when, how, and where is it produced. What does the shuttle do and why is it beneficial? And then finally, I'll go into some effects of endurance training strategies. So, what is lactate and its role? Well, previous thinking was that lactate was just this metabolic waste product from the process of anaerobic glycolysis or the glucose breakdown to form 2 ATP when oxygen was not present. But now, after many years of um, pretty diverse research in this area on lactate in the body, the more updated thinking, at least as far as exercise, is that lactate can be or is an additional fuel source in both aerobic and anaerobic conditions. And as we know from training, we're not always only anaerobic or only anaerobic. There's always this continuum of energy production in the systems that we're using to make ATP. But rather than lactate being this waste product, it is actually now we know or understand that it's more of a fuel source that we can use to make ATP. So lactate can also, when it's produced, be converted to glucose in the liver. So it can be um, an energy source in that way through a process called the Cori cycle. But it can also, lactate can be taken up by type 1 and type 2A oxidative skeletal muscle fibers, as well as the heart for oxidation and energy production. So, with this new thinking, we can really think of lactate now as this link between anaerobic and aerobic metabolism, or glycolytic and oxidative metabolism. So, when and how is lactate produced? Well, lactate is actually produced at rest, and we don't really think about it in that way because we tend to associate lactate levels with hard exercise or pain and that burning feeling. But we do produce lactate at rest, and resting lactate levels, as measured in the blood, are about 1 millimole per liter. So if you look at this graph on the right, you can see that in moderate or endurance, steady state exercise, or which is in blue, or the orange, which is heavy, and that's continuous exercise right around your FTP or critical power or lactate threshold. Um, and then severe, which is over threshold in the red line, you can see that the starting point for all those blood lactate concentrations at time point zero is 1 millimole per liter. So we do produce lactate at rest, and it's maintained around that concentration level um, in the blood, as measured in the blood. We also can increase lactate production, or we do increase lactate production early in exercise. So as we are starting out, um, our body has this epinephrine response, and that onset of exercise, we're using all energy systems. So it's predominantly as we start out anaerobic, and we are using, that muscle contraction is producing ATP in anaerobic pathways or through anaerobic pathways, which will generate some lactate. But what you can see here, again, if you just focus on this blue line, so it's endurance, or let's say just that's your zone 2, sub-threshold steady state exercise, you see around in this graph, minute 5 to 7, you see actually a dip in blood lactate. So it's just below 1 millimole per liter. And that's because, again, lactate is being taken up and being used as a fuel source somewhere in the body. We don't know exactly where. But then if exercise intensity continues, to increase from there, or at least stay at steady state, it'll fluctuate right around 1, maybe go up to 1.4 or so millimoles per liter in endurance exercise, steady state, zone 2. And then again, if you're looking at FTP, which is considered the heavy exercise domain, but still steady state, you'll see this rapid rise in lactate from 0 to 10 minutes, and then it'll sort of just kind of stay there because this is your functional threshold power, right? Or your lactate threshold where it you have this rate of appearance of lactate in the blood because it's hard exercise. It's more intense. We're recruiting uh, lots of muscle fibers and motor units. And eventually we're going to fatigue, right? So this is your TTE, or your time to exhaustion around FTP. That could be 30 minutes, that could be 40 minutes, it could be 20 minutes, it could be 60 minutes, 70 minutes, whatever. It depends on your training status. Um, but at that point, you're producing lactate, but you're also utilizing it, so that you have that rate of disappearance, which is kind of holding blood lactate fairly constant. Now, if you're above threshold, that's where lactate's going to continue to rise. And over maximal lactate steady state, or FTP, you're going to see that red line just continue to go up. And eventually you're just going to get tired and stop. So those are the three main conditions. You're going to produce lactate at rest, you're going to produce it early in exercise, and then if you're doing intense exercise, you're going to produce even more lactate at a faster rate, and it will continue to climb until you stop exercising. And I have here, this is the pathway. So glucose is going through glycolysis to produce ATP, a small amount of ATP, and the end result of that is also pyruvate. And then pyruvate can be converted into lactate under certain conditions, but it also is going to produce hydrogen ion. And I'll talk more about this process, but this is what it looks like from the metabolic process. So where is lactate produced during exercise? Predominantly, you're going to see when lactate is increasing around heavy and severe exercise, you're seeing it produced in higher amounts and more overwhelming amounts from these glycolytic producer cells, or these type 2 B fast twitch fibers that are producing large amounts of lactate. They can't really use lactate for energy. So as lactate concentrations increase rapidly within these type 2B muscle fibers, or these glycolytic fast twitch fibers, lactate can also exit those cells and go to the blood. That's where you're going to be measuring your lactate concentration, through your ear, through your finger. And those are the values that you're measuring. So those blood lactate concentrations. Now, remember, blood lactate will also flow to other tissues, like other muscle fibers, the heart, and other tissues in the body as well. So, but predominantly, let's think of the glycolytic fibers, those type 2 fast twitch fibers, being the big producers of lactate during exercise. So what happens when lactate is produced? Well, I just mentioned one of the things. So over to the left here, you can see in a fast twitch fiber, you'll have glycogen breakdown. Glucose is undergoing glycolysis, and there is going to be pyruvate produced, but then pyruvate will at some point be overwhelmingly producing lactate, because there is a buildup of NADH, there is lactate dehydrogenase, and there's not this need for pyruvate there. At these high levels of lactate, you're also going to have a buildup of hydrogen ions, and this is going to cause that muscular burn that you feel. And the buildup of hydrogen ions with the lactate is what's going to cause a decreased pH in your muscle. And what this does is it actually impairs muscle contraction and force production. And that's why if you're doing like a 45 to 60-second all-out effort that's purely anaerobic, you are going to feel that fatigue. It's going to get very hard. It's not so hard at 30 seconds, but when you go to 45 to 60, it starts to get really hard, and you're feeling that muscle fatigue. Primarily, this is one of the biggest reasons, because with that lactate production from glycogen and glucose breakdown, you have lactate, but then you also have that hydrogen ion, which is then impairing the muscle contraction and your ability to continue to produce force at that rate. So what else can happen? Well, we have uh, when lactate and hydrogen ions are produced in the fast twitch fibers, we also have some of this lactate exit those cells through the MCT4 transporter to go into the bloodstream. Again, this is where you're measuring your blood lactate concentration as it's going up during harder exercise. You see those lactate values climb pretty quickly. And then if you're staying right around your threshold, they'll kind of stabilize there. But if you're continuing to push supra threshold, you're going to see those values climb even higher. But that blood lactate concentration does depend on the work rate and the production of lactate by that muscle, by predominantly those fast twitch fibers. It also depends on the rate of removal, right, from the blood of lactate by the liver, because remember, the liver is a organ that can take up a lot of lactate and produce glucose from it. Other muscle fibers can also use lactate. So these are the slow twitch fibers, and also other tissues like the heart as well. But you see here, the slow twitch fiber can take lactate up from the blood via the MCT1 transporter. So it exits the fast twitch type 2B from the MCT4 transporter, enters your slower twitch or even type 2A oxidative fibers through the MCT1 transporter. And lactate can be converted back to pyruvate, which can then enter the mitochondria for ATP production via oxidative pathways or the Krebs cycle and the electron transport chain for high amounts of ATP production. It's a good thing. So this is what this lactate shuttle is. Think of lactate being produced at high rates in some tissues, like your type 2B glycolytic muscle fibers, and being used by other tissues, for example, your slow twitch fibers or your type 1 or your type 2A oxidative muscle fibers. And so there is this cell to cell transport of lactate from these producer cells or type 2B to the consumer cells or the type 2 A and type 1 oxidative fibers. Again, through the MCT transporters to exit the cell and to enter the cells and convert or take lactate from the blood, convert it to pyruvate, and then send that into the mitochondria. That is essentially the cell-to-cell lactate shuttle process defined. So what are the benefits of it? Well, I kind of alluded to this, but one, we see pyruvate go into the mitochondria just per normal circumstances from glycogen and glucose breakdown to produce ATP, yields pyruvate. Pyruvate can undergo oxidative metabolism or oxidative phosphorylation via the electron transport chain after the Krebs cycle. But then again, we see here in the cytoplasm in call this a slow twitch fiber, we have lactate that will enter and be converted into pyruvate via these, I'll just call them accessories to the MCT1 transporter. So then when we have lactate entering, it's actually converting back into pyruvate. And you see again, pyruvate will go convert into acetyl-CoA, which also comes from fatty acids. So really, there's no difference at this point once it's converted back to pyruvate and we'll go to acetyl-CoA. There's no difference in fuel sources. So while we always think of like, trying to prioritize fat oxidation, well, now we are yielding the same component entering the Krebs cycle from carbohydrate oxidation. Remember, that's how we're generating lactate, is through the carbohydrate oxidation, utilization of muscle glycogen, glucose, and we are getting to the same point. And so this is a good thing. We can create large amounts of ATP through utilization of now fats, carbohydrates, and lactate. So what is the effect of endurance training now? Well, we know with endurance training, one of the biggest benefits in the muscle itself is more mitochondria and more mitochondrial enzymes. This means we have more capacity for uptake and utilization of lactate for oxidation now. So here on the bottom, when we see the lactate shuttle, we see lactate going from MCT, or sorry, from the fast twitch fiber to the slow twitch fiber. Um, we can we have a greater capacity for this because now we have more mitochondria there that are available to take lactate via its whether it's direct to oxidation or whether it's via pyruvate, but we now have more aerobic capacity in the muscle through these mitochondria and mitochondrial enzymes, um, where the end result there is we don't have to produce as much lactate, right? So when we are producing lactate or favoring lactate production, it's because there's this part of it is there's this buildup of pyruvate, and that equation is getting backed up, and it's we're not going to overproduce pyruvate. So instead of that, we'll produce lactate. But now if we have a place to use the pyruvate, we have a place to use the NADH and the reducing equivalents. We have a place to take lactate for oxidation. Now we have a greater capacity for fuel utilization and ATP production. So again, think of the better your aerobic system and the better your oxidative metabolism, the more we can utilize lactate from glycolytic metabolism to now bridge these two main energy systems together. Lactate is this yellow kind of oval in between glycolytic and oxidative, but that means, or that benefit is pretty significant when your oxidative capacity, your oxidative metabolism from your aerobic endurance training is bigger. The bigger, the better in this case. Another effect of endurance training, and this is all, tied together, but in this pathway from pyruvate to lactate, we see it requires this lactate dehydrogenase enzyme. And so with more endurance training, this form of the LDH enzyme sort of changes. And again, it favors pyruvate production over lactate production. So what does this mean? So we're actually producing less lactate, which in a sense that's good because now we're also producing less of this hydrogen ion that yields that muscle burn, right? So yes, we can use lactate when it's produced, but if we're producing less of it because our oxidative metabolism or aerobic fitness is much better, that's also not necessarily a bad thing because we are now causing less hydrogen ion buildup and less muscle burn, and we're not causing the pH in the muscle to go down as much because of this fitness. So it's, again, a good thing. So that the LDH enzyme is formation change is one of the key components or the key reasons behind why we might actually produce less lactate and favor pyruvate production. But again, remember, we have a place. We have those additional mitochondria and those enzymes as a place for the pyruvate and the NADH to go with the Krebs cycle and the electron transport chain. Another effect of endurance training is increased blood volume and blood flow. So the central adaptations from, the cardiovascular response to aerobic or endurance training does impact this too, because we have more plasma volume increases. That's one of the first adaptations to endurance training. And then we have improved blood flow from the capillaries. When we think of exchange in the muscle through these new capillaries, it's improved. And so what this means is we have an increased rate of blood lactate removal when lactate is put into the bloodstream from these glycolytic fast twitch fibers. Now we have also an increased rate of removal by the liver, by the muscle, by other tissues like the brain, like the heart. And when we have this increased amount of lactate going to the liver, we now also have increased gluconeogenesis, or the production of glucose from the lactate. So you can see now lactate is not by any means a waste product, and we are utilizing it as a fuel source in the mitochondria for large amounts of ATP production. Um, we are using it in the liver to make more glucose, which is huge. And these are all benefits from endurance training from the peripheral standpoint in the muscle, um, within the muscle itself, within the capillarization around the muscle, and then from a central response of your plasma volume and blood volume. So, what type of training will yield maximum benefits for the lactate shuttle or lactate handling, or however you want to think about it? And we know that to attain some of these benefits, like good old fashioned aerobic volume or the zone 2 volume, does a lot of good, and it will help again with the plasma volume. So the circulation of nutrients, of lactate, of oxygen through the blood. It will also, zone 2 will improve or increase the number, and so the density and the content of the mitochondria, particularly in these slow twitch fibers. There's some intraconversion of the fast twitch fibers to become more oxidative or type 2A. So they have mitochondria, and you can see some of those improvements also. And those really kind of start to happen more with the little bit more intensive aerobic work, like the tempo and the sweet spot work that we have done quite a bit of. It's a little bit harder, but it's still very aerobic. And so that's where we're really seeing these mitochondrial changes take place. Yes, you can do a lot of aerobic volume, sure, but when you're thinking about, having 10 to 12 hours a week, maybe 14 hours a week, utilizing specific tempo and sweet spot type of efforts to gain some of these benefits a little bit more quickly, without creating too much fatigue. So we're doing it in a very intentional and progressive manner is really helpful. And that helps with the carbohydrate oxidation. It helps with, and that will yield lactate, right, through carbohydrate oxidation. But then we also have the additional mitochondria and the end place for the lactate to go. It goes, again, to the blood, to other tissues, to other muscle fibers through the lactate shuttle, and then also back to the liver as well. So here you can see all these mitochondria now through the endurance training, through zone 2, zone 3. And what is happening in the mitochondria is you're taking large amounts of pyruvate, producing less lactate, yes, but also when we are producing lactate, we're able to use it as a fuel source, that'll go back into acetyl-CoA eventually into the Krebs cycle and oxidative phosphorylation to produce large amounts of ATP in the mitochondria. And finally, we have these interval types that are like over under, so over and under FTP or your lactate threshold. We have other workouts that are like tempo with surges, sweet spot with surges, hard starts. We are going to start seeing a lot more of these dynamic intervals that have supra, so above FTP, like pretty hard efforts, mixed with sub-threshold tempo, sweet spot type of intervals throughout the same workout. And so why is that? Well, think about, again, if you look at this Venn diagram here with the green is the glycolytic metabolism, red is the oxidative metabolism, lactate is this bridge in between, or this link between the energy systems. If you think about these dynamic workouts or the over-unders or the tempo with surges, we're doing work across those energy systems, right? Like we're producing using fast twitch fibers, we're producing more lactate, and then we're going back under threshold at tempo, and we're utilizing that lactate. We are creating the demand. We're creating the lactate through carbohydrate oxidation, through high intensity intervals. And then we're going to tempo, let's say, and we're creating the demand for lactate as a fuel source. So we're utilizing now, in these sustained over under intervals, we're utilizing carbohydrate, we're utilizing lactate, and we're utilizing fatty acids to make ATP, all of them. This is an example of one of the workouts that you're going to see in cycle 4. And there's several of them, but I just chose one to illustrate this a little bit better. So this is an over under workout with supra, so above FTP surges. I don't know how long they are, but those are the yellow arrows, again, with the green outline. And so what those signify is we're using more glycolytic metabolism. So we're using carbohydrate oxidation in these muscle fibers. We're producing lactate. So that's the key there. But then with the red arrows, when we're going under threshold, that's where we're more using oxidative or aerobic metabolism to shuttle and take up and utilize that lactate to put it back in the type 1 fibers, let's say, or the type 2A fibers, to convert to pyruvate, and to put into the Krebs cycle and electron transport chain, to produce ATP. So we're going over and under and over and under, and we're creating the lactate, and then we're creating the demand, and we're allowing the slower twitch, or the oxidative fibers to utilize the lactate. So then we do a sustained amount of aerobic riding at the end of the workout, and we will still have, some elevated blood lactate if you were measuring it, but then the idea is that we are utilizing the lactate, we're utilizing fatty acids for energy production in that sustained aerobic riding. So what are the implications for performance here? Well, I said it earlier, but metabolic flexibility is one of them. So we can now maximize the availability of all these fuel sources: fat, fatty acids, carbohydrate, lactate oxidation. This yields better fatigue resistance, better endurance. We always have these fuels available, and our bodies are now highly trained to utilize them when they are available. So if we care about performance, that means we do want to be good at carbohydrate utilization, because this means better high intensity performance, better tolerance above threshold at more intense levels. What this also means is when we are better at utilizing carbohydrates for higher intensity, we are also now producing lactate. And what this means is now lactate now is not a negative thing. It is an additional fuel source, whereas historically we thought of it either being good at utilizing fat and sparing carbohydrates, but now for performance, we can maximize fat oxidation, we can maximize carbohydrate utilization, and the added benefit to that is having lactate as another fuel source. Does this mean better repeatability and TTE with the ability to produce carbohydrate and lactate and utilize lactate as another fuel source? I think so. And I don't know, this would be a hard thing to study, and obviously there's a highly individual component to that. But I do think that if you were to improve your ability to be strong in dynamic workouts where you're producing higher amounts of lactate and then able to utilize it, so tolerate it, shuttle it, and utilize it for fuel, then you have more ATP to work with. You have better energy production. You can recover from suprathreshold efforts better. And if you are at FTP, you can, in theory, hold that effort for longer. Okay, that's it. Thanks for watching.